So what does Lenz law says? If you have a circular conductor made of some metals and you are bringing a magnet towards that circular metal, and this is north, this is south. So what's going to happen? So obviously there's a magnetic field because this is north, this is south, and this will be go through this way like that. And this is south, so and this magnetic field, when it's coming to closer to that metal ring, obviously there's a change in flux because flux that the metal ring is exposed to is changing. So what will happen? It's going to induce an EMF in this metal ring. That EMF will create a current in this conductor. So what's going to happen is that because this is moving this way, it's going to create a current that's going to flow this way. So let's draw the direction of the current here. So that is this way. So now what's going to happen? Because of that induced current, there's going to be another secondary magnetic field created due to this current. So the secondary magnetic field is going to be this way. That's opposing the original magnetic field. Because if you look at the current direction, and you can easily say that this is going this way. So we have the primary magnetic field this way, and this secondary magnetic field, the magnetic flux, is opposing the primary one. So the Lenz law states that the induced EMF will create a current, that's a current, it's cause a magnetic flux that would oppose the changing magnetic flux that induce the EMF. So we have an induced EMF that always acts to produce an induced current in the direction, that's the most important thing, that causes the magnetic flux, so a magnetic flux. And this is the most important one, that opposes the change in flux that induces the EMF. So let's look at that again. So we have got an induced EMF, which is the red one here. So that always acts to produce an induced current. So the induced current is the one in yellow. It's causing the current that's in yellow. In the direction that causes a magnetic flux. So the magnetic flux caused by the induced EMF is the one in white. That opposes. So the magnetic flux produced by the induced current is opposing the original magnetic flux that induced the EMF. So it's quite confusing, but the important thing to note is that we have a changing magnetic flux this way, and because of that there's an EMF induced, and because of that induced EMF, because this is the one thing we need to know is because it's a closed loop. That's the reason that an induced EMF is creating a current. If it's not a closed loop, you won't see a current. Because of a closed loop, it's creating a current, and that current is creating or causing a magnetic flux that is opposing the original change in flux. So now we come to the law of conservation of energy, and what is that to do with the Lenz law, or what is Lenz law to do with the conservation of energy? So energy, the conservation of energy states that in the universe there's only a fixed amount of energy. That's the energy that was there when the universe began. And you can't destroy energy and you can't create energy. I mean, that's the law. You can't create or store energy, but you can convert from one energy to another energy. I mean, that includes mass as well, because mass is also considered as an energy. So that means that according to Einstein's equation, you can convert mass into energy. That doesn't mean you're creating energy, but you're basically converting mass into energy. Mass is considered as a type of energy. So looking at this one, so we see that the magnetic flux as a result of this induced EMF is opposing the original flux. Say, for instance, if the magnetic flux is not opposing the original flux, but it's going to be in the same direction as the original primary flux, what's going to happen? That both flux together are going to increase the current here. So that means we're going to get infinite amount of flux and infinite amount of current. That means we're going to get infinite amount of energy from nothing, because energy here is stored as magnetic energy, and that's what converted into this current, and we have got the secondary one that's opposing it. But that magnetic energy stored in a magnet is limited, it's not infinite. So that means if a limited magnetic energy here is going to create infinite amount of flux and infinite amount of current, that basically oppose the law of conservation of energy. So that is not practical, that doesn't happen. So that means Lenz's law supports the law of conservation of energy, and it gives an evidence to that.